Okay, so we're talking about both exponentials and logs here. And the basic idea here is if it starts in one form, put it in the other form to solve it. So that may be obvious, it may not, but you want to do that. And these are easier maybe without when they have a common base. At least they kind of work out nicer. So this one, like when they have a common base, you can just get the same base. Like in this case, 9 can be written as the prime factorization, which is 3 squared, and you go 3 to the x equals, and you might have gotten that without actually doing that. You probably knew the answer to that one, but it's x equals 2 would be the answer. Even these two, like 16 and 8, you might think, well, they don't really have the same base, but they could. So if you prime factorize 16, again, if you're having trouble with that, you could always get your calculator out, right? And it's scratchpad. So you get menu 32 factor 16. Whoops, 16. You get 2 to the 4th factor 8. You get 2 to the 3rd. So using that, we could write this as 2 to the 4th equals 2 to the 3rd. And then, of course, power of power, you multiply. So this is 2 to the 12x equals 2 to the 3rd. Therefore, 12x must equal 3. So we don't have to worry about the 2 anymore. 12x equals 3, divide by 12, divide by 12. You get x equals 1/4. And you can solve it. So again, if you see well, 27 and 81, maybe they could have the same base. So you can factor them. If they're not prime numbers, this is kind of your clue. Okay, let's prime factorize that one. Prime factorize that one. So that's 3 to the 3rd. So that's 3 to the 3rd to the power of x. This one is 3 to the 4th. So just solving that. That's 3 to the 3x equals 3 to the 4th. So those exponents must be equal. So 3x equals 4. And so x equals 4/3. And so if they have the same base, if they could have the same base, like those problems, you want to prime factorize. So if there's a number that's not prime, just prime factorize it and see if they get the same base. If they don't have the same base, we might have a problem. But let's just kind of work a few more here. So we just did 27. If you remember, that's 3 to the 3rd. So we have 3 to the 2x. So 2x must equal 3. Those exponents must be equal. And so you get x equals 3/2. So again, just same base. This one's a little tricky, and I want you to see this one. Once you've seen this once, it's a little easier the next time around. So first, just prime factorize 125. So if you don't know that, again, prime factorize, so menu 3 to 125 is 5 to the 3rd. So this is 1/5 to the 3rd. They almost have the same base. Like it's looking pretty good here. But there's one more step, and once you see it, it'll be easier the next time you see it. How do I get something in the denominator up to the numerator, or vice versa? What kind of exponent would do that? And hopefully you know it's a negative exponent, right? So now we have the same base exactly. We can compare, and so 3x must equal 5, right? The exponents must be equal here. Or sorry, I read that wrong. 3x must equal -3. The exponents must be equal. Divide by 3, and you get x equals -1. So that's just, kind of works out really nicely again. So if you can get the same base, again, so 81, well, we just did that one. That was 3 to the 4th. Let's just write that out here. So that's really 3 to the 4th. And now I have 3 to the -2x plus 2. So what must be true about those exponents? They must be equal. I don't need the 3 anymore. 2x plus 2 equals 4. Subtract 2, you get -2x equals 2. Divide by -2, you get x equals -1 after all that. So same base, if you get the same base, that's really a great way to solve these. But sometimes you can't get the same base. Like 59 is an odd number, 2 is an even number. You're not going to get the same base right there. So the method here is just change the form. So if it starts in exponential form, put it in log form. So this would be log base 2 of some number equals some number. So let's see, with logarithms, the exponent is equal, a log is or equals the exponent. So the exponent has to go over on this side and the 59 has to go here. We've solved this, right? So what is x equal to? Exactly log base 2 of 59. If this is in the no calculator section, that's the answer I want. If this is in the calculator section, and I say round it to 4 decimals, you would at this point have to just type that in your calculator. So you type in, log is control 10 to the x, and you type in log base 2 of 59. If you want a decimal, hit control enter, and it'll round it there. And I just went to the nearest 4 decimals, so 5.8826 is what that's approximately equal to for x. So again, this is 807, that's odd, that's even. They were not going to have the same base here, so let's just change the form. So it'll be log base 7 of, hopefully you're getting better at this. So let's see, the exponent goes on this side, and the number goes over here. You're almost done. I've got to solve for x, got to do one more step. So I need to divide that whole thing by 4. So that's the exact answer, log base 7 of 800 divided by 4. But at that point, if it was a calculator question, you would hit control divide log base 7, so control 10 to the x, log base 7 of 800 over 4. I'm going to put a decimal point that also gives you a decimal. So this would be x is approximately equal to 0.8588 to the nearest 4 decimal places. Try another one. 5 and 400 again, even odd, there's no way those have the same base, even if I prime factorize 400. So just change the form. That's the method. Log base 5 of a number equals the exponent, which is 3x. This is 400. One more step to solve here. So you want to divide by 3, divide by 3. That's the exact answer for x. If I asked for the approximate, you would type it in. Log, so control 10 to the x, base 5 of 400, all over 3. So x is approximately equal to 1.2409. Solve by graphing. So we've done this before. The method is to set it equal to 0, graph, and trace. Use the trace command to find the x values of the zeros of the graph. Okay, so you set this equal to 0, so we're going to subtract 13. So we get 2 to the x minus 13 equals 0. We're going to graph the left-hand side. So like these should be easy ones on the quiz and test if you just know the method, right? So some people had trouble in the last test, but it's really like the calculator is going to do most of the work here. If you just set equals 0, graph it, and then use the trace command, menu 5.1. Oops, menu 5.1. And you want to trace until you find that 0. I think I just passed it. It says the word 0 there, 3.7. So x is about 3.7. If you try the next one, set it equals 0. So this would be 3.5 to the x minus 234 equals 0. So I'm going to graph that one. 3.5 to the power of x minus 234. Looks like it crosses around 4 or 5 there. Let's just see though. So menu 5.1. I think I passed it. There it is. So by the way, just this does happen here. So occasionally, it looks like the y value is not 0. It actually is 0 if you hit more digits. Like it is pretty much 0 there. It's just having trouble identifying it as 0. So that happens. If it says it's a 0, the y value is 0, even if it has a scientific number notation there. So x is equal to approximately 4.35. That's probably a rounded off number. It might not be though, if you hover over it. No, it is rounded off. So, sorry. So that is approximately equal to that. I don't want to delete all. Okay. I think that is the lesson today. Let's just go back and look, since we have a few extra minutes. Let's do the PSAT. So stop it for a second, read this, try it. So if you drew a line like y equals x, where y is equal to x, we're saying when would the ordered pair be like this? Ordered pair would be the y value is larger than the x value here, right? So that point would be above the line y equals x. Y is actually larger than x there. This one, the y value is larger than the x value, so that would be above the line. This one, no, the y is smaller than x. Y is bigger than x, y is smaller than x. So there are 3 times where y is, we're trying to find, like, if the line y equals x, any point up here, the y value would be higher than the x value is. And so a point above the line, we want a y value that's higher than the x value. The y value is the 2010, so we need the y value to be bigger than the x value of 2000. And that's how you do that one.